Very good morning to all. Today we can discuss about the Barkhausen stability criteria, which is used for the oscillation and the subject analog electronics. So Barkhausen stability criteria. So what is the major requirement for this Barkhausen stability criteria? Whenever we are going to design any circuit, we have to satisfy some criteria. So what is the Barkhausen stability criteria major requirement is? It is used in electronics to predict whether a linear electronic circuit may oscillate. That is the actual motto of using this Barkhausen stability criteria. So it is actually formulated by a German scientist. Proposed in the year 1921. So it is commonly utilized in the design of electronic oscillators as well as general negative feedback circuits such as operational amplifier to keep them from oscillating. So how it is going to mainly it satisfies there are two conditions. One is the loop gain. What is that loop gain? The product of the feedback and the amplifier gain is equal to 1. And our second condition is the phase shift through the loop is either 0 or an integer multiple of 2 pi. That is 360-degree. So these two conditions are the conditions for a stable oscillation. So Barkhausen criteria is a necessary but not sufficient condition for oscillation. Certain circuits meet the requirement but do not oscillate. So therefore, these two conditions has to be satisfied for uh, achieving the oscillation condition. So first, so this is the basic block diagram of an oscillator. The two major components are the basic inverting amplifier with the gain A and the feedback network beta. So the feedback gain will be feedback factor is beta. That is, it is nothing but HF is the output from the feedback, which is equal to beta into H naught. H naught is nothing but the output which is fed back to the fed as input to the feedback network, and HI is the input to the basic inverting amplifier, and so the amplifier gain A is equal to HI by H naught. So H naught equal to A into HI and HF equal to minus beta H naught. What is the need for this minus beta is because we are going to use 180-degree phase shift from the output to the input because of this feedback. So it will be going to shift. It is by negative. So minus beta H naught. So substitute this 1 H naught equal to A into HI, that value in 2, you will be getting minus A beta into HI. So HI is equal to minus A beta. So since this its feedback is equal to the input, HI is equal to minus A beta HI. So minus A beta equal to 1. So when this minus A beta condition is called Barkhausen criteria, whenever equating the magnitudes of both sides A beta, it becomes A beta is equal to magnitude of 1. Okay. And the phase of itself must be same as HI, that is feedback network should introduce 180-degree phase shift in addition to 180-degree phase shift introduced by inverting amplifiers. This ensures positive feedback. So total phase shift around the loop is 360-degree. In this condition, itself drives the circuit, and without external input, circuit works as an oscillator. So the Barkhausen criterion for oscillation is total phase shift around a loop is precisely 0 degree or 360-degree or integral multiple of 2 pi. The magnitude of the product of the open loop gain of the amplifier and the feedback factor beta is unity. That is a magnitude of A beta equal to 1. In reality, no input signal is needed to start the oscillations. Only the condition must be satisfied for self-sustained oscillations. So based on this, there are three types of oscillations. Whenever the product of this A and beta is greater than 1, it is start the oscillation and the circuit adjust. So we can say it is going to be in the condition of over damped. And if magnitude of A beta is less than 1, it will be going to result in somewhat changes in oscillation, like a damped oscillation. So that is considered to be under damped oscillation. And magnitude of A beta equal to 1 is the condition for self-sustained oscillation. That is, at the more closer will be the sinusoidal waveform. This is how we will be generating. So this is magnitude of A beta greater than 1, the condition over damped, and decaying oscillation magnitude of A beta less than 1. Decaying means under damped, and sustained means a perfect sinusoidal waveform. That is nothing but your output, which is obtained magnitude of A beta equal to 1. So these are the two conditions, necessary conditions for satisfying a particular amplifier to act as an oscillator. Thank you.